Hello everyone, today we'll be working on a new GPU, I'd say. So this GPU is it's gonna be outputting 16 by 16, and we're gonna be using the IC chip called 74H C595, which is the chip we're gonna be using, and the resolution is gonna be 16 by 16, because we're gonna use 3 of this, and we're gonna have to use resistors, and there's gotta be like this 5 is good, and so we can wire them to display all the 16 by 16 for 1 bit a row. Yeah, 1 bit a row, because resistors can actually do 1 bit a row. So we're going to use 5 resistors at least, and wire them so they can display 16 by 16. So for today we're gonna be just using the Arduino Uno, or Uno R3, and now we're going to display just the binaries on the LED. It's gonna represent the colors, so we know that if it's 111, it's all white, 110 it's red, and 101 then it's yellow. Blue. No, green. RGB. So yeah, so that's how it's gonna be. Let's dive in, shall we? And so let's start. We're also gonna be using, and I think the main thing is the Devlog, isn't it? Okay, so we're also gonna be using a breadboard. Yeah, so we're gonna use a breadboard, then normal breadboard. I think this is a little too big. I don't know how to work around this website, to be honest, but this will do. Yep, this will do. So we're gonna donate an Arduino, but let's start with late or LED. So I think I'll just put it here. So the long side is positive, which is the anode. It's positive. And so yeah, we'll do as follows. So we're gonna give it a positive in the ground from the Arduino. I don't know how to put the Arduino. Pretty sure you can find it under the microcontrollers category. Oh, okay, so there you go. This is the Arduino we're gonna be using today. Oh, my bad. Alright, so here we have a 5 volts and the ground. Here we have here as well. So we're gonna use the 5 volts as a positive for all the rows, and we're gonna make the ground through here because Otherwise it gets very complicated. So yeah, these are connected, so I'm gonna have to wire the base and the ground from here. This will do. So let's start the simulation, and I guess it should be on. No? No, I actually don't know how to power up this thing. What does this look? And that's just if this system is on or not. And as you can see, it is. That this 5 volts should do, unless I. Oh, my bad. Okay, I just realized that I connected this to. I don't know how to use this thing, but it has to be there. Then it's gonna be on. No, is it on? Yep, it's on. And this thing is on. So maybe we switched this and on instead. Surely it is. Yes. So, oh, I don't even know why I switched that, but we're totally wrong. Should be like this, then it should be on. No, still not. Anode is positive. So you can see, maybe you can wire it directly, so you know what's wrong and what's not. This is anode, and then this is the cathode ray. Oh, I blew it up. Why? Absolutely no idea. Maybe that's because I forget that these states cannot draw 5 volts. They usually require 0.3, and yeah, that's why we gotta use 3.3 volt. Then it should be on. No, still it's big. So what we can do is I think we can remove this line, and I think it should work. And we're just gonna ground it totally, and yeah. Okay. This is like my first time I'm doing this on stream. I mean, not only on the stream, but I usually don't do this. So we're giving it too much power. Okay, look, let's put this aside. How do I even move the thing? How do I move it? I don't know, something like we're just gonna use power supply. Where is it? There we go. So we can let's remove these wires. And the negative one can be here, and the positive one is gonna be here. We're gonna make it draw 2 volts, right? So yeah, I will do it. Alright, still we don't see anything. So what could it be? So we're giving the negative and the negative. Oh shit. Okay, now I know why. This cathode ray should connect to this, and now it should work. Yep. That's because we are giving it too much power. And as you can see, this will do. Alright. So that was the problem. I didn't know that I didn't connect this. It's my bad. I suck. I know. So we're gonna give it a 3.3 power, and on ground here we have connected the cathode ray to the ground, and yeah. Why did it blow up? Because we didn't use a resistor. So we're gonna put them here and wait, yeah, weird. We wanna select this and yeah, so like it should work now. Yep, there we go. See, the registers are okay. The register, not registers, it's a single one. So yeah, we might need 5 of them. This is just for one blade, and that is not gonna be good. So maybe what we can do is also it's gonna be string necessarily right. Yeah, still it should work. There's not much more here, not over as well, but just to see. Oh no, I don't need that. We can make this here and yep, still works. But if you really want to control it, we're gonna have to connect it somewhere else here. The analogs. Right. So yeah, we don't need this anymore, but we can keep it here. Look, it doesn't move it whenever I want it to move. Oh, it's because we're in simulation. Okay, my bad. Right. So I think it's not by hand for the stream, but I'm gonna be working it by hand after this demonstration. So now we know it works, but we gotta make this work on every line, because if I use another blade, like let's say here, and let's connect the power here, so it's gonna give it power, and the ground should be from here up to there we go. But so like we're gonna put it like this then, okay? And so to make this work we have to think, let's move it somewhere else here, I suppose. Somewhere else here, and we can move the wires to here and this one here back. So now I think everything should work fine. And also let's connect this. We are either gonna see blow up or it's blown up, and this didn't because I didn't connect the ground, which I have to, and it's gonna blow up now. Right, good. So now they have blown up. So let's check. There's this no highlighting. Let's see an image. Okay, maybe for this purpose we don't need that to be that much. Oh. So even if you did it, I think we're gonna just blow the fuck up. Yeah, we even blow them because it is the power from here to here. Yeah. So this is still gonna blow up. So what are we gonna do for that? We're gonna have to make it from here, and I think remove this one, and I think from our register both of them lights up, as you can see, but it's gonna be missed just. So like, okay, now we know we can use one register, and up to 5 registers are gonna be enough. Right. So now we gonna program the Arduino. And here we're gonna code it. Yep, that's the last one you have to. Wait, so you cannot code. No, I will text. Yeah, continue. Alright, so that's what we want. So we built in. So I think we can use like A1 and A1 high and A1 low, and we can connect A1 to this and remove this one. So like it's gonna be blinking, I suppose. Yep, as you can see, it works. Yep, it's working. So we're gonna start the simulation, and we're gonna have to like put 8 of these lights or LED lights, and we're gonna have to make them turn on, whether it's white, like based on the RGB. So so it's A1. A1 is for all these rows, it controls them. So we'll try to make it in a single breadboard as possible. Alright. Okay. What happens here? It's not. My bad. I was actually checking on my other screen. So right. We're gonna need like a lot of them, and instead of powering up the whole thing, we're gonna be using, I think, further each one of them, because we won't control each one of them, I suppose. So I think you can get the advantage of the numbering A1, A2, A3, A4, A5. I think. Or maybe not. So if the stream is lagging, just know that I am streaming on mobile data, because for some reason our home network is not working, and yeah, that's pretty bad. Hopefully they fix it, but they will never. Another they're pretty shitty company. They wanna say their name. So these are the digital pin, analog and power. When you get this one working, it's gonna blink. It's on and off, on and off. Yeah, it's drawing good power actually. So, pin 11. This one, I think it's data pin 13. Oh, my bad. 13 clock pin, and pin 8 is a latch pin. So you're gonna connect them to each one of them. I think we're gonna be like 8 more. Third, fourth, 8, 6, 7, 8, 9, and here the 10th one comes. So they should work. Like if everything is white, it should show us like everything should be on. If it's red, I think the first string should be on, like R, G, B, A. Yeah, I think I should actually have the A, but we're gonna keep this on. Yeah, we're gonna no, that's it. All right, so this pin we set up digit G to 11, which is no, remove no. This one, this is 11. So we're gonna set the data pin to 11, and here, here, latch 3 to 8. Oh no, and we're gonna say Devlog 3 to 13. Oh no, gosh. So we're gonna set out those. So we're gonna set the P node data P output, and now we're gonna repeat the same thing with the 3 of them. Latch. Okay, yeah, I'm done. I shouldn't have chose all 3. Right. So we're gonna. So first of all, we're just gonna leave the loop and work on the setup, so as long as the audio is on, it should stay on, depending on what color it is. So we're gonna install right to the latch pin, which is 8 speed, and we're gonna set the latch speed to low, and digital right pin, and the latch pin to high, but I'm assuming this we never tell where the things comes from, like I'm not convinced, but I'm not an English speaker, so yeah. So we're gonna tell the binary, so like if it's what color it is, so we're gonna shift out data pin to the clock in, and to be 111 and 1. I think that should be it. 1 2 3 4 5 6 7. Yeah, I don't know, I think that's it. So we're gonna set the latch pin, which is 8. Here, and yeah, we don't want this at all. So we start the simulation. Shift okay. Shift was not declared in this scope. Wait. Oh man. Oh gosh. This guy just did shit out. You see what I mean? Okay, there you go. So let's connect all 8. Wait, let me check. So if the stream is lagging, just know that I'm with mobile data, and mobile data is not that good for stream, but I literally had no choice, to be honest. Literally no choice. So what we can do is, or what it says on the documentation is we should use the microcontroller, yet another one. It's actually not a microcontroller, but it's the 74HC 595 IC 595. This 8-bit register. That should do. And let's move them all here. No. Move it here. Register, you're gonna be here. Alright, cool. So still it should work. It should give out the same result as it does. We don't need this now. So like it's gonna have more space, So this is the power, and I think we're gonna power it directly from the 5 volt. I think it's 5 volts, but I'm still away, so what we can do is even though it's a maze, complete maze, we can set it here, then it's gonna power up, and where's the ground? And for the ground, we're gonna use another ground for this row. And yeah, connect the box. Now this thing should be on. And it is on. It's just that we cannot tell. So let's put 0. Where is it? 0 can output 0. So we're gonna connect the data pin to the computer actually. So we're gonna connect this to the data pin, which I believe was 11. Another code, yeah, and the clock pin, which is the 13, I think. Which one is it? So this is the first output, just clear. Picture, you're gonna connect this to the clock pin. This is the third pin, I think it's this one. It's completely hidden. Oh, we can do this, right? So I'm gonna do that. Or this one, I don't know how though. This one is the one that is the difficult ways. No. So this one connected to 11. We're gonna do it to 11. We're gonna down here. No. We're gonna down here. Wait, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, no. 2, 3, 4, 5, 7, 8, 9, 10, 11. Yeah, so this is 11. We're gonna have to move it here. Yeah. So, this is not gonna create a maze. And that the data pin, if this is 11, then 11 to 30, this is 13. You're gonna go here, there we go. And now we're gonna connect it to 30. There we go. Alright. So now it's connected. So I think you're gonna connect from output 1 to 0. So the ground will, I think, will remain the same. It's gonna have register for each section, but yeah, let's see what we can do. So instead of the anode is gonna be removed. The anode which was the large thing. Let's see the code. The eighth one was large B. Yeah, so large is should connect to it. Well, this one we're gonna go okay. Alright. Right. So the eighth one actually. So there we have no. There we go. So we don't learn this one. So now we nothing should happen. Nothing happens actually. So we're gonna do the output. Let's not try to make it a mess. So we're gonna go out here. Oh no. That's good. Anode. Because anode ray is the positive one. So this should be on. Yep, and it is. So output 2. Should also be on, but only if we do this. And I think it should do. No, it doesn't. Well, just never connected the anode ray, the cathode ray. I mean, it should be on. There we go. So like it's 1.8 for every out there. Gosh, it's kind of painful. I can see that. So once we design this out, like probably accessory manager should be working on a bare metal. And it's gonna be on a real stream. Hopefully I'm not gonna leak my face. How about I make this red? Because I mean, yeah, these are positive. Like same color coding like that. So for as always, it's a maze, but you know, it's not that maze. Goodbye. Okay. Yep. And should do. We should have put it there anyways, so we would have like no space to work on. But I don't know. I don't know how I'm gonna go through that. And I still proceed to go here. Maybe it's not bad at all after all. So here you have to put 7. There you go. 8, 9, 10. Oh my god, bro. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, we got 10 of these. I don't think we actually need 10 of them. All we need is 8. We represent 60 values. No, 4 bytes of data. No, I mean that's 3. Because we're also gonna be working with the B. Must. So yeah. So I don't think we actually need this too, and yep, you see it's 9s and 10s. Alright. So let's try running and this should be good. So should this be? Now we're gonna wait. So here to here, here to here. I don't know if the register is gonna handle that, but we're gonna see. Cool. So we're gonna run this simulation, and it's no, the last time is not on. So first of all, this from what we can see, way to die for real underneath the ground. Gosh, this is so dumb. This is so dumb. Oh, I don't know how the restart even working. Yep, the ground should be connected like this, and so it's one. Yep. Wait, does it start from 0? No, it doesn't. So where is 1? Okay, so yeah, 1 has 1, 2, 3, 4, 5, 6, 7, 8. No. So it doesn't look that weird. Not about the weirdness, but you know. Okay. So like output 1, there you go, 1. Oh, so it never connected 3. So we're gonna have to rearrange every fucking thing. So what I'm gonna do is come on. We're gonna move them one by one. Wait. So we should start from this one. No. Here. This one. Here. This one. Here. This one right here, and this one here. Cool. What? So yeah. So we can come on. Why is it not going? Like everything was moving like second, you know, nothing does. Except the original board. Come on. Was it? No. Okay. No. Oh my god. I forgot. Think space. Think card. Alright. So this is what we want. No. It's this. So doesn't move. Still looks. No. Still that's enough. It doesn't move. Okay, this. I was about to say like, I don't know, something. So let's like agree so much the rest of the industry will be on there, and there we go. And that's gonna be rates just like the others. So it should work now. And it does. See, everything is on. It's getting there so quickly, but it works, you know. So now let's check if we change this 1, 2, 3. Yeah. Might have put it in. So like 1, 2, 3, 4, 5, 6, 7, 8. And how about making it like 1, 2, 3, 4, 5, 6, 7, 8. And if you turn on the video, it's very not correct. Come on. Come on. Come on, bro. Turn it on. I thought I really got it working. But I think not. So yeah, if every bio the policy is 0, then nothing should be on. Means something is incorrect on the circuit, I suppose. So the data pin, which is 11, is 11. Which one is it? This one. It is connected to input, and it's correct because that's what gives the value. As you can see here is the data pin. And clock, which is 11. No, clock is 13. The 13 is this. Output register clock. Good, I mean everything is good. And this is connected to 8. Yep, there you go. So I don't know what's wrong. So let's check by let's wait, okay, we can't, this rate is high and so on. Well, let's see. Okay, so now it's actually working now. Here, of course, writing it on the data pin. Yeah, okay. MSP first. What's wrong with the light? Yes. Of course I'm correct. I knew. So okay, I thought I'd give like 50 minutes, not like, no, I mean 30 minutes, and it already took around 45 minutes. It's quarter left, 1 hour, so I don't know, I can't tell if you're doing it or not. So the data pin it just shifts out to the pin into pin. And I mean shift, now it's no Arduino, yep, shifts out a byte of data 1 bit at a time, starts from either the leftmost or least, or the rightmost. So we're sending from the leftmost to the rightmost. Yeah, we write them as follows. To be honest. Okay, oh, right. No. Right. So that's the only area we have, and should be out better. It's not. Let's make a first few of them on, and everything's gonna be on, which sucks. Yep, everything is on, unfortunately. Yeah, accept. So the pin which outputs HP upload don't take me anywhere. For the sake of it, please. So is everything set it up correctly? We did it all perfectly. What if you ask? But while also trying to check this out. Okay, it's not loading. What's wrong? It's gonna work. Yeah, just up and down and just wait, I guess. As pushing turn off, flow out, utility turns on. Well, that's not the case here. No matter what we do, your life's logic. I mean, there's no loop, you see. So it's Tetris. What's new? I didn't see anything new. Because it was just like how it was like before. So I see it's gonna do the same thing. It's gonna show us, yep. Make sure all E. Okay, so there you go. Why not testing from the example? So there definitely is an issue here. Oh, so the output enable should be grounded? Is that how it works? Like, it's this one. So it's saying that I should ground it. Here I left one ground. So am I gonna blow it up? Okay. That didn't blow up. Current through IO pins. DB honored makes it the absolute maximum of 40 MA. This may prevent them with Arduino. So we don't want to do those. So I think I can just power on. Yep. Alright. Arduino pin, leading ground, Arduino pin, leading ground. Alright, so instead of using power from Arduino, we're gonna pull this bad power in, and now we're gonna power it. First of all, the power should be can put it here, it works, you know. And the ground should also be no. So the output number. Right. And it's like about things off. How didn't it blow up? Wait, the max you could do is what? So like 5. And 5 blows it up. So it's either this. Let's try removing this one and check if it still blows up. We're gonna just put another with grounded one. And let's try now. And let's grounded it. Doesn't work. Let's just put it the other side. There you go, now it works, I guess. But it never goes. That means it's not working. It's not on. Or maybe it is working. Then this should work better. I'm not. Doesn't. So alright, the 595 goes up with 5 the directly from 5. What is he gonna say? How many ladies you want? What percent player is he? One charger battery? Just fire both. Is that good? Is it because we still grounded to this? I think we shouldn't. If you're gonna be consistent there, then I shouldn't. You should ground it all by this, and this should work. Yep. No, it doesn't. All the lids are safe though. Alright, so okay, we're at the past hour. We had no viewers. So now we're grounding it. We can also ground okay. We're in simulation. Let's put to here. And it should, I mean it does work, but not the way it's supposed to. Okay, so zero by 0 by 1, 2, 3, 4, 5, 6, 7, 8. So it's at 8 euros. And if you turn something, you know, something is wrong. God. So now I think we should also change the ground of this one to, you know, get another end from here. I mean, obviously you can't do that in Unreal, but no, you can't. So you can do it here as well. Pin orientation placement. Confirm that the DIP notch go to rotation. Learning as I go. I mean, if this was in real life, just think that how much it would cost me blowing shit up. Let's just say paper, so you know. What is the IP? Parents converted IP launch. Program speaker needs excellent PC. What? So like, okay, I can't do that. Like, imagine connecting this to this and this to this. It's gonna blow the whole thing up. Yeah, I mean, expected. I'd say. I mean, I'm grounding the original itself, and that's not how it works, baby. Even this way, it's gonna go up. No, and they're still on. There's no freaking ground here. Maybe you can go only like from here to here. We can share grounds, you know, and it's gonna go up. Is it the same circuit as the other? Alright, so everything's on. It shouldn't be still. MR and OE pins. MR is active low pin must be tied high to high voltage late output, which normally I know what you need to do. I mean, it helps, you know. Alright, I don't know. What is this? Fuck you, NVIDIA. Alright, so red coverage or D now. No. Arduino. And what was it? Forgot, generally. Shift out to 8.
Let's learn how to control multiple LEDs using Arduino's digital outputs and a breadboard. Looking next, take a look at the work plane, where I'll add a breadboard from the components panel. The rows of a solderless breadboard are connected inside, allowing you to connect components by plugging them into the same row as each other. The special long rails along the edges are for easy access to power and ground. It's a best practice to always connect 5 volts and ground to these long rails as a starting point for any Arduino circuit. Try it for yourself in Tinkercad circuits. Double-click along the wire to create bends you can use to tidy up your circuit. To change your wire colors, select the color in the inspector, or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5V are typically red, and those connected to ground are typically black. Let's recreate the blink circuit using the breadboard. Add an LED to the breadboard so its legs go into 2 different rows. If your breadboard's up and down, you can use the rotate tool. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. This breadboard circuit is electrically identical to this pre-wired circuit. You can build either way in the editor, but if you're also building a circuit with physical components, the breadboard will help keep your virtual circuit looking the same. Let's add a few more LEDs to this circuit along with their companion resistors. For each, connect one end to ground, in this case through the resistor, and the other end to a different digital output pin on the Arduino board. Let's use the code blocks editor to create this animation effect. To make the speed of the animation adjustable, add in a variable that will serve as the amount of time between state changes. I'm going to call mine animation speed. At the beginning of the program, set the variable to your desired time in milliseconds. Drag the new variable onto the wait block to set it to whatever animation speed is set to. Don't forget to do the dropdown for milliseconds. Use another output block to set the next pin, 12, high, then low, with a pause after each. Duplicate this block for as many LEDs as you have left, and change the pin numbers to correspond to the connected LEDs. Test out your code by starting the simulator. In the text editor, you can see the Arduino code generated by the code blocks. Before the setup, we can see our variable is created. It's called int because it's an integer, or any whole number. Inside the setup, just like last time, the pins are high in hover over row. And you can also refer back to this photo of the breadboards inside. You'll get plenty of breadboard practice in the upcoming lessons and become a pro prototyper in no time.
Hello guys, in this video we are going to see how to use the shift register IC 74595 with Arduino. So let's get started. Going to see how to use the shift register IC 74595 with Arduino. So let's get started. In the previous video, I have explained the basic things of IC 74595. This is the IC 74595. Pin number 8 and 13 are connected to the negative rail. Pin number 10 and 16 are connected to the positive rail. Now I'm putting the LEDs. The negative pins are connected to the negative rail. With the positive pin of the LED, I'm connecting 220 ohms resistor, LED 1 to LED 8. As we know, pin number 15 is output 1, so we have to connect pin number 15 to LED 1, and the last output, that is pin number 7, should be connected to the LED 8. Pin 15 to LED 1, pin 1 to LED 2, pin 2 to LED 3, pin 3 to LED 4, pin 4 to LED 5, pin 5 to LED 6, pin 6 to LED 7, pin 7 to LED 8.
Alright, so from what I see here, I actually connected them to positive, as you can see, to an odd race. And that's now how it works. I think I'm gonna connect this to here, I think. No. Yeah, I'm gonna have to connect this to right here. And I don't think it's gonna work, but I was trying, isn't it? But first of all, not everything is powered up. So, how about now? Wait, not everything is. Wait, so what? No data from Central City. Oh my god. I'm very struggling for my one view. So cheers to everyone. Send me I don't know. Like topper here. I said yes. Oh god. I'm incorrect then. I'm gonna have to redesign most of the things. So I think I'm gonna have to all this thing here. And what is this? Just connect here, bro. And the ground, it should be here. And yeah, this will do. Start simulation. It's not on, but maybe it's because that is here. Now let's make everything 1. One, two, three, 4, 5, 6, 7, 8. Yep. And if the person is on, then that is a success. Because I will just have to repeat the same thing for the rest of us. And then okay, it could be my internet. It could be how bad my internet is. There you go, and it's still not. No. To be honest. No, just 5. Go back. And okay, data batch code. What is that? Modify the ground is from here, but maybe directly. Okay, that's gonna go the thing. It's gonna fuck it up. Maybe we can use one of from this series and it's still gonna work because it's grounded. Or maybe you can ground it from there's no ground there, so maybe you can put it here. What? So, this is so confusing, not gonna lie. Yeah. We have this connected to this. But this thing is never connected to here. Maybe that's it. Okay, so it's right now since the and we broke because this is why I feel and why did it happen? I have no absolutely idea. I mean, of course, it's because we're drawing more currents than it accepts, so. So you see this is some kind of
now we have to connect the input of.
So behind the negative part, the negatives, and the positive part here, and it's for the negative. So we did it absolutely wrong. Oh gosh, it's still saving.